Dear viewer and students, in Chapter 1, Lesson 2, we explained how to find the slope of the straight line using 2 points or using a vertical change or a horizontal change. In this lesson, we will learn how to find slope of a curve at a known point. We also learn how to find the first derivative of a function using the definition. My name is Tawfiq Omar Uthman, math teacher. Follow us and let us start our lesson. Slope of a function. If y equal fx is a function and passing a point p c f of c, then the slope m of a tangent line passing through this point is. To find the slope of the tangent line, we must first of all draw a function passes through a point p c f of c and take another point on the graph of the function. Let be point q. If this distance is delta x, then and this one is delta y. As you can see here, if we drew a vertical line on y-axis, here it gives us f of c, and here it gives us f of c plus delta x, which means delta y is equal f c plus delta x minus f of c. And now, as we know that the slope of a straight line is y2 minus y1 over x2 minus x1. And here the slope of the secant line PQ is f of c plus delta c minus f of c over delta x. And now if we move the point q on the graph of the function and become closer and closer to the point P, here we can see that delta x approach to the zero. Delta x approach to the zero. That means to find the slope of the tangent line, we must take the limit of the secant line when delta x approach to the zero. That means the slope of the tangent line is limit delta x approach to zero f of c plus delta x minus f of c over delta x. This is a slope of the curve at the point P. At the point P. Be careful, this way for finding slope of a function is called definition way. Example. Find the slope of the linear function f of x equal 2x minus 3 at x equal 2. As we learned before in chapter 1 lesson 2, this is a linear function. We can compare this function with the equation of the linear function, form slope and intercept. Slope and intercept. Comparing between these two equations, we can see that the m is equal to. This is the slope of the function f of x. If you use it the way of chapter 2 lesson, if we used chapter 1 lesson 2. But to use the definition of the slope of the curve, slope is equal limit delta x approach to 0 for f c plus delta x minus f of c over delta x. And now, because we have x equal to 2, that means c is 2. And now replace 2 in place of c. It becomes limit delta x approach to 0 for f2 plus delta x minus f2 over delta x. And now replace 2 plus delta x in place of x from the equation of the function. Then it becomes, here you have 2, then open a bracket, and in place of x write 2 plus delta x, 2 plus delta x, then minus 3. This is from here is this part, the part of f2 plus delta x. Then it becomes minus. Then to find f of 2, replace 2 in place of x. It becomes 2 times 2 minus 3. And simplifying this limit, it becomes 2 times 2 is 2. 2 times delta x is 2 delta x minus 3. Minus 2 times 2 is 4. Minus times minus is plus 3 over delta x. Cancelling 4 with minus 4 and minus 3 with plus 3, the limit becomes delta x approach to 0, 2 delta x over delta x, cancelling delta x with delta x, then the answer be 2. As you see here, slope is 2, and here slope is 2. And if we draw the graph of the function, you can see this way. If x is 2, then 2 times 2 is 4, 4 minus 3 is 1, then the point be 2, 1 here. And then if we take the x be 3, 3 times 2 is 6, 6 minus 3 is 3, then the point be 1, 2, 3 here. As you can see, when we moving on the graph of the function to the right 1 unit, then we're going up 2 units. That means the slope is delta y over delta x, which means 2 over 1, which is 2. This is 3 ways how we can find the slope of the straight line. Example number 2. Find the slope of the function f of x equal x squared plus 1 at x equals c, at x equals 0, and x equal minus 1. Here, we cannot do as we do it from the example before. Now, to find the slope of this curve, of this function at these 3 points, first of all, we can find it at x equal to c by using the definition of the slope of the curve, which slope is equal limit delta x approach to 0 for fc plus delta x minus fc over delta x. And now limit delta x approach to 0, replace c plus delta x in place of x. It becomes c plus delta x squared because we have x squared plus 1 minus, and now to find f of c, replace in the function in place of xc. Then it becomes c squared plus 1. And now simplifying this limit, it become c square 2 times c times delta x is 2c delta x, then delta x square plus 1 minus c square minus 1. Cancelling c square with c square and plus 1 with minus 1, and limit b, limit delta x approach to 0, 2c delta x plus delta x squared over delta x. As you can see that in the numerator we have a common factor which is delta x. Take it out, then limit delta x approach to 0, delta x, open a bracket, here 2c delta x is become 2c, because 2c delta x divided by delta x, cancelling delta x with delta x remain 2x. Then delta x square over delta x, when the delta x is cancelling with delta x remain delta x. And now cancel delta x with delta x, it remain limit delta x approach to 0, 2x plus delta x. Replace in place of each delta x 0. It become 2c plus 0, which equal 2c. That means the slope of the tangent line at x equals c is 2c. And now to find the slope of the tangent line at x equal to 0, that means c is equal to 0. c is equal to 0. And here c is equal minus 1. Then the first time replace the c with 0, then m is become 2 times 0 is 0, is a slope of the tangent line when x is 0. And now when x is minus 1, replace in place of c minus 1, then slope is equal 2 times minus 1 is minus 2, is the slope of the tangent line when x is equal minus 1. Definition. F is differentiable at x equals c if and only if f is continuous at x equals c, which means f of c must be defined and limit when x approach to c for fx must be exist, and limit of x approach to c for fx must equal fc. And we have another condition which slope of the function equal f prime of c, which limit of x approach to c for fx minus f of c over x minus c must be exist, and this is called a derivative at x equal to c. Or f prime of x equal limit delta x approach to 0 for fx plus delta x minus f of x over delta x must be exist. This is the derivative at any point must be exist. Mathematicians use the different notation for the derivative of f. Sometimes some of these notations are f prime of x, they will write f prime of x, which notes as that is a first derivative for the function f. or df over dx, or dy over dx, or dfx over dx, or dxy, or y prime. Definition. If the graph of the function is given, how we know that this function is differentiable at x or not? Look at the first graph. As you can see that this function is not continuous because the right limit is not equal the left limit, which means limit is not exist. Because this function is discontinuous at x equals c, then it is not differentiable at x equal to c. The second one. As you can see in the second graph that the function is not defined at x equal to c because you have a gap point here. That means this function is discontinuous at x equal to c. Because it is discontinuous at x equal to c, that means this function is not differentiable at x equal to c. The third graph, as you can see here, that the function is not defined at x equal to c, and the limit is not exist. That means this function is discontinuous at x equal to c. Then it's not differentiable at x equal to c. In this function, as you can see that the function is continuous at all real numbers, but because you have a sharp point here, therefore the function is not differentiable at x equal to c. In other cases, the function can be differentiable. Example. Find the derivative of the function f of x equal 2 over x. That means the first derivative. Write the definition of derivative f prime of x is equal limit delta x approach to 0 f of x plus delta x minus f of x over delta x. And now replace x plus delta x in place of x here, which become limit delta x approach to 0, it become 2 over, in place of x, replace x plus delta x, it become 2 over x plus delta x. Then minus f of x, write f of x here, which is 2 over x. Be careful, every time this part is f of x, this part is minus f of x. Everywhere when it asks you to find the f of x, this part is the f of x, the minus of f of x. And now limit delta x approach to 0. We are going to make a common denominator by multiplying x times x delta x, and then after that multiply 2 times x and 2 times delta x, which become x times 2 is 2x minus 2 times x plus delta x. And now simplifying this limit, it become limit delta x approach to 0. We write it numerator here by opening this bracket 2x minus 2 times x is 2x minus 2 times delta x minus 2 delta x, and write denominator as it, x plus delta x, and make delta x, or take the delta x inverse 1 over delta x. And now cancelling 2x with minus 2x and delta x with delta x, the limit be delta x approach to 0 minus 2 over x plus delta x. And now replace in place delta x of 0, it equal minus 2 over x plus 0, which is minus 2 over, this is the derivative of the function f of x, which means f prime x equal minus 2 over x squared. The function is not differentiable at x equal to 0, since it is not continuous. Theorem 1.3. Differentiability implies continuous at x equal to c, which means if a function f is differentiable at x equals c, then f is continuous at that point, or x equal to c. That means if a function is differentiable at a point, then it is continuous at that point. Is the inverse of previous theorem true? Not, because if f is continuous at x equal to c, maybe f is not differentiable at x equal to c. If x equal absolute value of x is continuous at x equal to 0, but it is not differentiable there. To prove that, take limit when x approach to c, fx minus fc over x minus c. And now, because we have c is equal to 0, then replace in place of c 0, it becomes limit x approach to 0. In place of fx, we're replacing absolute value x minus f of 0 over x minus 0. Become limit of x approach to 0, absolute value of x minus 0 over x. Then limit is x approach to 0, absolute value over x. To find this limit x approach to 0 from right, it becomes x over x because x is bigger or equal to 0. And limit when x approach to the 0 from left, then it is minus x over x less than 0. X over x is 1 and minus x over x is minus 1. That means the right limit is not equal the left limit. That means this limit is not exist. Because it is not exist this limit, that means the function f is not differentiable at x equal to 0. That means the function is continuous but not differentiable. Example, if limit delta x approach to 0 minus 3 plus delta x squared plus 9 over delta x, then fx is equal. Here, replace in place of 3 plus delta x, x. That means the function f of x is equal minus x squared minus x squared. That means B is a correct answer. Another example, if f prime of x is equal limit delta x approach to 0 for 5 minus 3 times 1 plus delta x minus 2 delta x, then f of x is equal. As we said before, replace in each number added to the delta x, and place it with x. Then write here 5 minus 3x. That means the function is 5 minus 3x. That means C is a correct answer. If f prime of x is equal limit delta x approach to 0 for 3 minus 4 times 1 over 1 plus delta x squared plus 1 f of x, then find f of 1. Compare the equation f prime x equal limit delta x approach to 0, 3 minus 4, 1 plus delta x squared plus 1 over delta x, with the limit delta x approach to 0 for f 1 plus delta x minus f of 1. That means this part of these two equations are equal, minus f of 1 and plus 1. They are equal. Therefore, f of minus f of 1 is equal plus 1. Multiplying by minus 1, then f1 is equal minus 1. That means B is correct answer. Example, if f prime of 4 is equal limit delta x approach to 0 for 2 over delta x plus 1 minus 2 over delta x, then f of x is equal. Here, to find f of x, because we have here 4 and we have here 1, we cannot replace x in place of delta x plus 1, because these two 1 are not equals. Therefore, we know that comparing this limit with the definition f of prime of 4, which equal limit of delta x approach to 0 for f 4 plus delta x minus f of 4 over delta x, we can see that these two parts are equal. This part, f of 4 plus delta x, with the 2 over delta x plus 1. Therefore, f of 4 plus delta x is equal to over f of 4 plus delta x is equal to over delta x plus 1. And now, we must write something equal 1 and be 4. To make this one 4, we can write this one with 4 plus delta x minus 3, because 4 minus 3 is 1. And now replace of 4 plus delta x, which means f of x is equal to over, in place of 4 plus delta x is x minus 3. As you can see here, C is a correct answer. Example, if f of x is x associated to each real number, the greatest integer less than or equal to the number x, which of the following is false for the fx? To find f of 3.23 is equal, because 3.23 is between 3 and 4, we are taking 3. That means it is true. And now we have f of minus 1.25. This number is between minus 2 and minus 1. We are taking a smaller one, which is equal minus 2. It is true too. F of x is continuous at x equal 2. To prove that, we must first of all draw the graph of this function. To explain that, this is the graph of this function. To find a limit of this function at x equal to 2 here, the limit x approach to 2 from right for fx is limit of x approach to 2 from right for the floor, which equal floor of 2, which is 2. Because floor, every integer number is an integer number. But when we approach to the x from 2 to 2 from left for fx is limit of x approach to 2 from left for floor is equal floor of 2, which is equal 1, because when we approach to the 2 is take 1. The right limit is not equal, the left limit is not exist. Because our function is not continuous at x equal to 2, then this function is not differentiable. That means it is true. The correct answer is C. Another example. For a function g, we are given that g minus 1 is equal 3 and g prime minus 1 is equal minus 2. What is the equation of the tangent line to the graph of the g at x equal minus 1? It's given us that the g prime minus 1 is equal minus 2. That means it is a slope of the tangent line at x equal minus 1. And it gives us that g of 1 is equal 3. Therefore, we have a point here, minus 1, 3, the point of the tangent line. And now we can use the form of slope and point for finding the equation of a line. Y minus y1 is equal mx minus x1, when it equal y minus y1 is 3 and slope is minus 2, x minus x1 which is minus 1. Simplify this equation, then 2x plus y is equal 1, which means C is a correct answer. Another example, the tangent line to the graph of the function f at the point 2, 3 passes through the point 7, 6. The value of f prime 2 is equal. And now to answer this example, we know that f prime of x is equal m, which is slope of the function. And now we are going to draw the graph of the function. We have, first of all, point 2, 3. 2, 3. And now we have another point, 7, 6. 7, 1, 2, 3, 4, 5, 6. This is 7, 6. And we have a function passes through the point 2, 3, like this. And now we are drawing a tangent line passes through these 2 points, this way. And now we want the f prime of 2. That means we know we want slope of the graph at the point 2, 3. To find the slope of the graph, we can here use chapter 1, lesson 2. As you can see, this distance is delta x, changing horizontally. This is equal to 5. Why? We can find in 2 ways. 1, 2, 3, 4, 5. Or we can say 7 minus 2 is 5. That means delta x is 5. And this is delta y. As you can see, 1, 2, 3. That means delta y is equal 3. Or we can say 6 minus 3 is 3. We know that the slope of this line, which is tangent line, is equal delta y over delta x. That means slope of this line is 3 over 5. Because it is a tangent line, that means the f prime of t, that means derivative at x equal to 2 is 3 over 5. That means B is correct answer. Here we reached the end of the video. Please do not forget subscribe the page and share it with your friends so that everyone will benefit it. and get each new video. Write your comment if you have any question and press like button, and thank you for watching. Goodbye.